Data East Back to the Future provided to me for some rehabilitation. The battery in the battery holder that used to be there has, which was removed now, leaked, and it leaked down onto a couple of the tip 102s right here. They were tip 122s, now they're tip 102s, and I replaced those. Also replaced that connector right under it. A little bit of corrosion had reached that connector. Also replaced the power connector, always good policy to have good power, and installed NVRAM. Comment was made that one of the pop bumpers was not working, yeah, and the right flipper's not signaling the computer. Those are going to be switch problems on your specific game, because here's your special solenoid circuits. I've tested those, and I'll show you in just a moment. Those are all working, and the switch matrix is also working. So let's put it into test. Hey, everything's okay. I don't have a soundboard connected to it. There's no issues reported with the sound. One thing with Back to the Future ROMs, it's annoyingly slow on this display test. Everything does work on here. I'll let it get through each of the characters. Yeah, annoyingly slow. Next test is switch test. And I shall use my Pinatech tester to walk through all the switches in column 1 and all of the switches in row 1. And this shall prove that all of the switches in the switch matrix are working. Here's switch 64, just for completeness. Your flipper switches, there's the right one, here's the left one. They're working just fine. So let's move on. The switches are all working properly. And the lamp test, working as it should. Data East provides the facility for a little bit of an expanded lamp test. It'll let you test all the returns by hitting the credit button, which is button 3. So you can see all those are working properly. And it'll test all of the columns now. And those are working properly also. And then it gives you the facility to check each individual lamp, which really isn't that useful, I don't think. Maybe somebody's found a better use for it. It's annoyingly slow also. All right, everything's working there. Next test is the coils. So that super bright blue one is the AC select relay coming on, and you'll see it's pulsing. Watch this. It goes back and picks up a couple. That's just a characteristic of the way Data East wired these signals. Now here's your special solenoids, and it's only going to do 5 of them. They didn't test the 6th one. I did test the circuit, and it is working. There's 1, 1A, 2, 2A, etc. So those are all working properly. Now I'm going to take I'm sorry about that blinding blue light. I'm going to take a ground wire like this, and I'm going to rake the special solenoid inputs like that, and you will see all the special solenoids light up. Let me let it get past that test. Okay, here we go. 1, 2, 3, whoops. 1, 2, 3, 4, 5, 6. So all the special solenoids are working properly. Next test is, we can test each individual coil, but we don't need to do that. And we'll skip the VOOC test, and the game will go back to the boot process. You've got the lamp matrix working properly again. No coils turned on, as is correct. Game board, this MPU is good to go. I shall get the power supply that came along with it, which was a bigger project actually, because the capacitor had leaked on it and caused quite a bit of corrosion. Also, there was a little bit of a leak on that ground loop connection there, so I put a new one on there, and I'll conformal coat that PCB so it doesn't corrode in the future. Thank you so much. Back to the future. Dady's Back to the Future power supply. And I see this fairly often on this model of the power supply. What happens is that this capacitor here leaks, and the way Dady's designed this is there's a trace that runs from the bottom of the Zener diode up to here, and it's so close. There's a via right there where I'm pointing. It's so close to this big fat trace here that the electrolyte from this capacitor leaks onto this location, and then it creates a conductive bridge, and it kind of sparkles when you turn it on. It's kind of cool looking. But anyway, it spooged this whole area here, so I had to replace, these caps I usually don't replace. These are high voltage filter caps, but these two 5401, or 5551, 5401, a couple of 5228 Zeners, one N4004 diodes, left this cap, replaced the big 5-volt filter cap. This power supply was also blowing one of these 7-amp slow blow fuses, and originally I thought it was from the high voltage over here, but it turned out the bridge rectifier, this is a new one, was shorted. I'm going to send that back to the client so they can fiddle with it if they want. Also had to remove this high voltage transistor, the MJE350, and I put some new heatsink compound on there, but it was good. I just replaced it. It's good to go. I think that's it. So I have tested this, but let me show you what I do here. I'm going to turn it on. You can see the GI lights are working properly, and this little button here exercises the GI relay, so that's working correctly. Now I'm going to use my probe to test the 4 voltages, and I have lost my ground contact, so let me connect that back up. All right, so I'm going to go down here and test the 5 volts. And you got 4977, that's just fine. Here's the minus 12, and then the plus 12. And here's the big test. Let me switch hands. What I do here is I put these empty female housings on top of these connectors. It prevents you from ever bridging the contacts inadvertently and causing yourself a problem. So here's the first negative high voltage, and here's the positive high voltage, both right on. And then again, the 5 volts is piped over here. Minus 12 is piped over here too. This should be 12. And then you got a whole bunch of pins with ground. That's different from Williams. And then another 12. And then several pins with 5 volts on it. So this power supply, after being rehabbed, instead of being tossed in the trash and replaced by something that's inferior, is back in business, and it'll be good for the next, 37 years or something like that. Thanks so much for sending it.